Hey, Mom. What's that whistling? No, it's not. The one that's making this song? It's a bird? Or is it a toy? Oh. This one of the people said that they'd join when they could in a few minutes, but to start without them. But I haven't gotten a response from the other people.
You told them you were waiting?
Yeah, I texted those who I had the numbers, and then I emailed the other two. I don't have their numbers.
Who said they're not ready yet?
A guy.
to the email or text?
I have a text with him. He said to start without him. So I'm thinking maybe I should just go over with myself how to do it. And then, I don't know. Because I don't want to be on here like later than 6. But I don't know.
So, you sit there and wait till they use the number or?
No, well, right now I'm recording. And so when they join, it'll just come up on my little screen. It'll say like, blah 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 has joined your Hangout. Or
So you have to.
yeah, I have the Hangout. I'm the group leader for this week, so I'm in charge of starting it. Whereas when I was not the group leader for like other weeks, I'd just be sitting there waiting for an invite when they.
Go, go, go. So when you start recording, just
I am recording right now.
you just wait.
I'm just yeah, because I don't know.
So but then all the
Yeah, it'll pop up, and then I'll see his or her face on
how
here.
do they do it when they're not doing the thing?
So I think maybe one girl forgot and the other guy forgot. This one guy never comes. So there's 5 people in our group. I'm thinking that the girl forgot and that one of the guys forgot. One of the guys never comes, and then the guy who texted me said that he would be late. So I feel like it might just be me and him. But I don't want to go past 6.
So can you start by yourself?
Yeah. Yeah. Yes. I'll go ahead and pray. Heavenly Father, we're grateful for this day. We're grateful for our many blessings. We're grateful for everything that's done for us. Please bless that those who are not with us in the group meeting will join soon, and please bless that we might have Thy Spirit be with us to be able to work on our activity and we see these things in Jesus Christ. Amen. Okay, so the inflection points and concavity practice worksheet. I have the problem kind of worked out. So first you take the first derivative of the function, and then you find the second derivative of the function, and you should get something like this. Down here, this stuff right here. Okay, and then you're going to set that equal to 0 to find the inflection points. So when we do that, we set the numerator equal to 0. So we get 36x squared minus 36 equals 0. And then when you solve for that, you'll get x equals plus and minus 1. Then we want to solve for when the function is undefined. So we do x squared plus 3 to the third cannot equal 0. And then we solve for x. So we will get x squared equals negative 3. So x equals plus or minus I square root 3. but we're not going to have any imaginary numbers on our graph, so we don't have to worry about those. Those aren't going to be inflection points. So the only ones we need to worry about are 1 and -1. So then, with those, we're going to draw a number line, put -1 and 1 on there. Then we're going to pick values below -1, in between -1 and 1, and above 1 in order to see if the second derivative is positive or negative. And if it's positive, that means that in that interval it's concave up, and if it's negative in that interval, it'll be concave down. So when we plug in, let's say -2, we get a positive number. When we plug in 0, we get a negative number. And when we plug in 2, which is greater than 1, we get another positive number. So our interval looks like this down here. Okay, so that tells us that it is concave up on the interval -infinity to -1 and 1 to infinity. And it will be concave down from -1 to 1. Okay, so that's number 1. It just wanted us to find where the function was concave up and concave down. Next, let's do number 2. Sorry, I'm just erasing my whiteboard. Okay. Number 2 says find any inflection points for the function. And we have f of x equals x to the 4th minus 4x to the 3rd. So first step to find inflection points, we have to find the first derivative. And we will get 4x to the 3rd minus 12x squared. So now we find the second derivative. And we'll get 12x squared minus 24x. Okay, now to find those inflection points, we set that equal to 0 and solve for x. So we can factor out a 12x. So we're going to get x minus 2 left over. So if we use the zero product property rule, we can set both of those things equal to 0 individually, the 12x equal to 0 and the x minus 2 equal to 0. So we'll end up getting x equals 0 and positive 2. So those are our inflection points. All right, let's do number 3. Okay, this one says find any inflection points for the function. And this function is a little bit more complicated. It's x over x squared plus 1. So to find the first derivative, we have to use the quotient rule. So we're going to do low d high minus high d low over the square of what's below. So low is x squared plus 1. Derivative of the high, or the top, is 1 minus high, or x, times the derivative of the low is 2x, all over the square of what's below. So we get something that looks like this so far. Then we want to simplify that so that when we take our second derivative, it's not so messy. So that will simplify to x squared plus 1 minus 2x squared on top, which simplifies to negative x squared plus 1 over x squared plus 1 squared. So that's our first derivative. This one right here. Now we're going to find our second derivative. And again, we have to use a quotient rule. So when we do that, we do low d high minus high d low all over the square of what's below. So get something kind of messy that looks like that. So when we simplify this, we're going to end up getting basically just 2x to the third minus 6x all over x squared plus 1 to the third, because if you look at that top and bottom, they've both got an x squared plus 1. So we can cancel one of those with that one and then with that one. Or with this one right here, I mean. So that leaves just 3 of those on the bottom. So if we factor out the top and set that equal to 0, we'll get 2x times x to the second minus 3 equals 0. So we get x equals 0 and plus or minus the square root of 3. And on the bottom, when we set that equal to 0 to see what would make it undefined, we get an imaginary number. And we're not going to have any imaginary numbers on our graph, so we don't need to worry about those. So our inflection points are just going to occur at 0 and then plus and minus negative, or plus or minus square root of 3. Okay, number 4. We're doing the same thing, only f of x is going to equal x squared plus 1 over x squared minus 4. So when we take the first derivative, we do the same thing. We're going to end up getting, when you simplify it, negative 10x over x squared minus 4 squared. Okay. When we take the second derivative and simplify it, we're going to end up getting 30x squared plus 40 over x squared minus 4 to the third. And again, we're going to set that equal to 0 to find inflection points. And then we're also going to set the bottom equal to 0 so that we can see when the function is going to be undefined. So the top, when we set that equal to 0, we're going to get an imaginary number. So again, there's no inflection points from that. When we set the bottom equal to 0, we're going to get x equals plus and minus 2. Okay. Those aren't actually inflection points though, since that's on the bottom. That tells us that those are vertical asymptotes. That's where the graph doesn't touch. So it's actually not an inflection point, it's just a point where the graph kind of changes direction or does something weird. So on this one, there are no inflection points. Okay. So let's go over the second activity. So compare and contrast information from first and second derivatives. So first derivative stuff. So first you set f prime equal to 0, or find when it's undefined. Second, solve to get critical values and points. These are going to be your potential extrema, or max and minimum values, local or absolute. 3, make an f prime chart, or a number line. And then 4, use that chart to find intervals where f is increasing or decreasing. Step 5, to find the extrema. It's going to be a max or min when the slope changes from positive to negative or negative to positive. For 6, we want to use the first derivative test to identify extrema. So if it goes from positive to negative, that's a maximum. If it goes from negative to positive, that's a minimum. For second derivative, first step, you want to set the second derivative equal to 0 or find when it's undefined. Second, you want to solve to get your potential inflection points. Unlike we saw in our activity, just because we get some numbers doesn't always mean that it's going to be an inflection point. It could be an asymptote. 3, we want to make an f double prime chart, or a number line. 4, we're going to use that chart to find intervals where f is concave up or down. 5, we're going to use our inflection points, or we're going to define our inflection point as a point where the concavity changes from positive to negative or from negative to positive. And then we're going to use the second derivative test to identify those inflection points. So whenever the interval is positive, then that's concave up. If it's negative, that's concave down. And using all of that stuff, you should be able to graph functions and their basic properties, like where they're concave, where they have a maximum minimum, and the basic shape of the function. So that's it for those two activities. I'm still waiting for one person who says they're supposed to show up, but hey, Mom. Can I ask you a question? So I went over both activities, and I'm still waiting. Should I keep waiting for the person? It's 5:27. 5:30. Okay. She was late.
Hey, Jessica. Oh, man.
Hey.
Am I the only one who's shown up?
Yeah, so far.
Ah, cool. Okay. I think we have 2 activities for today, though.
Yeah. So, yeah, I kind of what's going on now. And there's flexible contact practice and then the practice.
It sounds kind of choppy on your end.
Oh. Okay. Is it the inflection point practice?
Let me see. I think we're on week 10, day 5. Activity A. Yeah, it's the inflection points.
Okay.
Okay. I'm just opening up some of the files here.
Okay.
Okay. Has Jacob or is it Allison? Have they texted you back?
Only Jacob has, and he said that he would be late, but I think he's planning on joining.
Okay. Okay. So we could get started, and then when Jacob shows up,
Mhm.
fill him in on what we've been doing.
Okay.
Okay, if I said the opening prayer.
Yeah, go for it.
Okay. Father in heaven, we're grateful for this day. We're grateful for technology that we're able to meet together and to understand more of this calculus class. As we go through these activities today, we ask thee to bless us with the Holy Ghost so that we may understand and learn and be strengthened by each other about inflection points. We ask thee, Father, to help us with this, and we give thee thanks for all the blessings that thou dost give to us. We ask in the name of Jesus Christ, amen. Okay.
Okay.
I've never been really good with graphs, and I'm pretty sure that's what all of this is about.
Okay. So, yeah, this is mostly just finding first and second derivative and solving for 0, or setting it equal to 0 and solving.
Okay.
So on the to find where they're concave up and down, we need to find the first and then the second derivative and set it to 0 and see what we get, and then see what it would be if it was undefined, and then tell us.
Okay. So is that first derivative going to give us concave down? And the second one would be
No,
concave up?
first derivative would tell us like where the maximum and minimum would be. But on this one, we're just looking for concavity. So we really just need the first derivative to get us to the second derivative.
Okay. So working on the first derivative here, just do the difference formula. So it's just going to be 0. We have 6 times x, oh, hold on, 2x all over the bottom squared. Which is going to come down to negative 12x all over x squared plus 3 squared.
Okay, so that's what I got.
Okay. Then we got to take the second
And then
derivative.
we find
Okay, so second derivative is, so do the same thing. We bring the bottom to the top. And multiply by a derivative, which is negative 12. Minus, and then negative 12x times 2, and then using a chain rule, I'm going to do the inside, 2x all over x squared plus 3 to the 4th, since it's cubed again. So then this comes out to looking like, let's see, negative 12.
So we can cancel out one of those x squared plus 3's from the top and bottom. That way we don't have to boil quite as much.
I see. So we're going to be doing negative 12 and plus, let's see, 2 times 2 is 4. 4 times 12 is 48.
So we've still got one of those x squared plus 3's next to the 12 because it was squared and we're only canceling out one. So we should have negative 12 times x squared plus 3.
I see. So this one over here, this one right there is gone, and then we subtract the power by 1. So this turns into a 1.
Right.
Okay. So yes, this will be negative 12x squared minus 36. And then just kind of adding up all this stuff in the middle, doing all the product rules here. So that's negative 48. So that makes this whole thing positive 48x squared.
Right?
Yeah, x squared. So then you add the x squares, or both of the x squared units together, and that's going to give us 36x squared all over this business.
And it's the third on the bottom.
What's on the top?
On the bottom it should be x squared plus 3 to the third.
Oh, yep, you're right. You're right. Okay. Then we set each of these equal to 0, you say?
Yeah, you set the top equal to 0 and then the bottom equal to 0. And see what we get.
So let's see, I'll work on the first derivative first.
You don't have to do the first derivative.
Not the first one. Just for this.
Not the blue, just the red.
Okay. So 36x squared minus 36 equals 0. Then x squared plus 3 to the 3 is 0. So we're going to get, pretty much this is going to boil down to just x squared is 1. And you take the square root of both sides. So x is going to be plus and minus square root of 1, which is just 1.
Okay.
And then over here, that's what you got on that side, I'm guessing?
Yeah. Mm-hmm.
Okay. So we're allowed to take the square root,
Yeah, so on
the cube root of each side of it.
cube root.
So we get x squared equals negative 3. And the square root of both of those, well, that's going to be I.
Right. So since those imaginary numbers will not appear on the graph, we can just disregard those.
Okay. We're just concentrating on those, which we have positive 1 and negative 1.
Right.
So what are these representing?
So inflection points, those are where the concavity changes
Oh, okay.
and where it's concave up. So then we plug in, we do a little number line. Plug in a value below -1 and see if it's positive or negative. Then we plug in a number between -1 and 1 and see what sign that gives us, and then a number bigger than 1.
Okay. That makes sense.
And then again, we're plugging it into the second derivative function.
Okay. So we're going to do, let's say -2. -2 squared minus 36. Oop,
Okay.
that's gross. All over 2 squared plus 3 cubed. Gonna bust out the calculator. 36. This looks like on top we have 108. And on bottom, got 343, which simplifies down to, oh, that's just it, 108 over 343.
Yeah. Okay,
that's
So
positive.
that tells us that, right?
So now we need another number to know if they're going concave up or concave down on the interval of +1, or sorry, -1.
So from -1 to 1, now we want to pick a number between those two. Because we know that it's going to be concave up, since it's positive, from -infinity to -1.
Uh-huh. Okay. So let's do, I'm going to use green. So 36 times 0, it's just 0, so 36 negative. Let's say 0 squared is just 0. It's 3, so 3 cubed is 27. So we get -36 over 27. I think that can simplify
Okay,
that
So
for
that's negative.
4 over 3. And that's negative. Okay. So
So
because,
now do we want to plug in 2?
yeah, let's do 2. I'll do just to change things up. Squared minus 36 all over. What do you get for this? Have you plugged into already?
I got 108 over 343 again.
Okay. Okay. So it's positive, negative, and then positive.
Great. So that tells us that it's concave up from -infinity to -1, and then from 1 to infinity.
Mm-hmm. Concave up. Yeah, so this whole thing is just going to be concave up.
Except for between -1 and 1. That's going to be concave down.
Okay.
Like my number line looks like, so -infinity to that can be concave up. 1 to infinity is going to be concave up. -1 to 1 concave down.
Okay, I see what you're saying then. So our graph is actually going to be looking like, it's going to be doing this kind of a thing.
Kind of, yeah. And we don't even have to like graph these. We just have to say when it's going to be up and when it's going to be down.
Okay. So in our case, we've got -infinity to -1 and 1, gross. Let me say this, 1 to infinity is concave up. And then -1 to 1 is concave down.
And not that this matters super a lot, but on her answer case she had all the parentheses as just like curved ones. She didn't have any bracket ones.
No brackets.
Because like when at right, so at -1 and 1, it's not concave anything, so included in the concave up or down.
Okay. All right. So that pretty much answers our first question then.
Yep.
So our second one says find any inflection points for the functions. So she's not asking for concave up or concave down anymore. She's just asking for the specific inflection points.
Right.
So we're going to be taking the first and second derivatives again and finding what x is when we equal both the top and bottom to 0. Or in this case, it looks like it would probably just be just equaling it to 0. Okay, so working on the first derivative here. I'm going to zoom in a little bit more to give us more room. So we get 4x cubed minus 12x squared, and then the second derivative is going to be 12x squared minus 24x. So when we equal that to 0, what are we going to get? 12x squared minus 24x. This is about what you have so far?
Yeah.
Okay. So we're going to take an x. Let's see. We could take an x out. And then do both these. So x equals 0 or zero equals 12x minus 24. Add to one side. So it's going to be 2. X equals 2. So x equals 0 and x equals 2.
Yep, that's what I got.
Good. Okay. Well, that's easy enough. Want to crank on the second one? Or the third one, I guess?
Yeah.
Okay. So we get x squared plus 1 to 1. So it's just that. Minus x times 2x all over x squared plus 1 squared. This comes out to looking like squared plus 1 minus 2x squared. So that's just going to be negative x squared plus 1 all over squared plus 1 squared.
Okay.
We can take out all right, no, we can't take out anything from that to simplify it because of
No.
that negative x.
Right.
All right, so then the second derivative is going to be, again, x squared plus 1 squared all over x squared plus 1 to the fourth times negative 2x minus x negative x squared plus 1 times 2x. Wait, no, we have to do the product or the chain rule.
Chain rule.
So we have x squared plus 1 times 2x. That. So.
And then we can cancel out an
So
x
same-
squared plus 1 on top and bottom.
Yeah. So this is going to give us negative 2x to the third plus, no, minus 2x. And then doing some, I'm going to just start canceling some of these out just right up front. So let's say 3, that's 1, that goes away. So we're left with 4x. So it's going to be negative 4x cubed Let's see.
Positive, right?
Actually, I think I'm getting ahead of myself. Just because those negative signs always trip me up.
Yeah.
So we had negative x cubed plus 4x. Okay, so then applying the negative sign, we're getting that. All over x squared plus 1 cubed. And this simplifies to, let's see. Nope, that's going to be just 2x cubed minus 6x. All over x squared plus 1 cubed.
Yay.
Okay. Thanks for your patience, by the way. All right.
No, thank you.
So now we're going to have to set this.
So now we said, yeah, the top equal to 0 and then the bottom.
0. Okay, so here we go. Cubed equals 0. I will do 1 at a time. Okay. So we're going to do, take out an x, which gives us 2x squared minus 6 equals 0. So x equals 0. Or 2x squared minus 6 equals 0. So it's going to be x squared of 3. So it's going to come down to that right there. X equals plus or minus square root of 3. Now we got to do the bottom. And just for sake of time, I'm going to do a quick cheat, and it's going to be just the random imaginary numbers.
Yep.
So you need to worry about that. So those are inflection points there. Those 3.
Great.
All right. Sweet. Now we're on the last one. Okay. Let me zoom in. And here we go. So we get x squared minus 4 times 2x minus x squared plus 1 times 2x. All over x squared minus 4 squared. This is going to be 2x. Well, you just take out one of the, nope, I have to do this. So we get 2x cubed minus 8x minus 2x cubed minus 2x. All over x squared minus 4 squared, which all this boils down to is negative 10x all over x squared minus 4 squared. That look right so far?
Yeah.
Okay. We get our second derivative. So second derivative. Deep breath. Okay. X squared minus 4 squared times negative 10 minus negative 10x times 2x squared minus 4 2x. I'm just going to simplify that again so it just looks better. So we get 4x x squared minus 4. Okay. All over this guy, which again we're going to just take one of these on the top. Oop, fail. Going way too fast for myself. Okay, so slash that, turns to 1, get rid of that one. So we're left with negative 10x squared plus 40, and then Applying all this is going to be positive 40x squared. 40x squared. Okay. All of that over 6, or x squared minus 4 cubed. And that's going to come down to 30x squared plus 40 all over x squared minus 4 cubed. Okay.
Okay.
So now we're going to do 0 again for each, the top and the bottom. Bottom is going to be an imaginary number, so
Bottom won't be an imaginary number. The top one will be, though.
yeah. All right, I'll have to crunch that out here in a second then. So we get, really this is just negative 4 over 3. Negative 4 over 3. And square root of each side. It's going to give us positive negative 4 over 3i. So that's imaginary on the top.
Mhm.
And then the bottom, though. So just cancel that. The bottom is going to be x squared minus 4 cubed equals 0. So x squared equals 4. X is positive or negative 2. Okay. So that's
Okay.
our inflection point there.
And then those are actually not even points because they're vertical asymptotes. So there are no inflection points for number 4.
Really? So the denominator answer always comes out to being x asymptotes?
Yeah. I think so. That's honestly why these weren't.
So our answer sheet just says there aren't any inflection points.
Oh, yeah.
Weird. Weird. Graphs are weird. Never liked graphs so much.
Mhm.
Okay.
Yeah.
And then what's our second activity?
It is to compare and contrast information from first and second derivatives.
First and second derivatives.
Mm-hmm.
Okay.
So really, we're just writing down the steps for like doing the first and second derivative test and stuff.
Okay. First derivative stuff, second derivative stuff. Interesting. So I never got to see
Yeah, I
any.
kind of had to look at the. I was just gonna say I kind of had to look at the key to see what she was wanting from that.
Okay.
So, yeah. On the first one, you're just saying that you set f prime equal to 0 or find where it's undefined.
So the first step after getting the derivative is to
First step is, yeah.
Okay. Oh, that makes sense, because if it's undefined, then you have to do some other rules to it, or if it's 0. Or actually, I'm thinking of integrals.
Oh yeah. Yeah. So on her key, it said set f prime equal to 0, or find where x is undefined.
Equal to 0, and see if it comes out as 0 or undefined.
And Set f prime equal to 0, or see where f prime is undefined.
I see. So this activity, she's really just wanting us to list out steps like this.
Yeah.
All right.
So like number 2 would be solve to get your critical value.
Solve to get the critical values.
Mm-hmm.
So after we get the critical values, if we're applying the same rules from our first activity, right, then
we make like a little
we need to
f prime chart
set interval.
or a number line.
Yeah. So let's do make a chart or number line.
Yeah.
Chart of number or number line. Number line with critical values. Set as test points. Does that make sense for?
Yeah. Yeah, that makes sense.
Okay. Then from there, test different numbers in between values.
Yeah.
Okay. Or let's see. What's a more sophisticated math definition for that step?
I put use the chart to find intervals where f is increasing and decreasing, but
Okay.
I don't know if that sounds any better.
Let's say find where f prime of x is increasing or decreasing. Between critical values. Critical values and actually there's a, how did you put it again?
I just said use the chart to find intervals where f is increasing and decreasing. So you can just put where f prime is increasing or decreasing.
F prime yeah, we'll say where f prime is increasing or decreasing. Or decreasing. Okay. And then from here, determine which intervals concave up and concave down.
That would be for second derivative. For first derivative, you determine which critical points are a maximum or a minimum.
Okay. Let's say find or determine maximum or minimum critical values. critical value points. We'll say that. Okay. Yep. Okay. And then for our last step.
The last step, when I looked on the key, she just said use the first derivative test to identify extrema.
I don't know
So
what
I
the
don't
first
just use the
derivative
first
test is.
Yeah.
So she just says to use the first derivative test to test what again? Use first derivative.
It just says to identify extrema.
Okay. All right. So then the second derivative stuff. So it's going to be the same.
And these are really similar to first ones.
Yeah, so it's
Yeah.
going to be find if f of x equals 0 or c.
F double prime.
I'll just copy over this. Hello. Yeah, cut it out. Here we go.
And then make it F double prime instead of F prime.
Good idea. Do double prime there. Make that red. Solve to get critical values. And-
Only instead of critical values, they call them inflection points.
Okay. So we'll say solve to get inflection points, or solve to find inflection points.
Yeah.
Inflection points. Okay, and then this is going to be the same thing, doing a number line. Is that right? This is going to be the same step?
Yeah. Yeah. Mhm.
Okay. And then same with 4. Find where f double prime is increasing or decreasing. So which of these steps would actually change?
Well, on 4, it says instead of increasing or decreasing, it says to find where it's concave up or down. But that's
Okay.
kind of the same thing.
I'll copy and then change it in a second. Up or down. So number 5 is going to be different because we're not really looking for maximum or minimum critical value points.
No, on hers it just said identify inflection point.
Just to identify the inflection points.
Yeah.
And then the last step after that, probably just to do the second derivative test to identify extrema again.
Yeah.
Okay.
Only instead of extrema, they say inflection point again.
Okay. Okay. So that's both of those activities there.
Yay. Have you taken the test yet?
Oh, not yet.
I haven't either.
I'm actually a little nervous about this one because I'm not sure it's actually going to be the same as usual, just because we're
Yeah.
not doing the whole like understanding what we're doing and having to do these kind of things with like writing sentences or essays about them.
Yeah.
So I'm not sure what to expect on it.
Yeah. Well, did you want to go over anything else, or do you want to be done?
I think this was good today. Thanks for your time.
Sounds good to me. Yep. All right, I will send you the link.
Okay. We'll see you later
Okay.
then.
See ya.